All right, this video I'm going to talk about DOAS units. This particular project had two DOAS units on the roof. They were provided by Druitt Modular Comfort. They're both Daikin products. My management style is really digging into the submittals, digging into the specs, and creating a on Bluebeam schematic that's relative to the job that it is. I think that sometimes the contract drawings just don't show what's going on for our field installation team as best as they could or should. So I try to take all the pieces to the puzzle and create these drawings that show, um, kind of the skeleton of what we're building. So it helps visualize that. So, anyways, the DOAS units are direct to outside air systems that bring in 100% outside air for ventilation. There is no recirculation on this system from the air. So it's 100% in, 100% out. This building has 8 floors. And so these serve as fresh air and exhaust air for all 8 of them. So I'm just going to get into this overview. DX coil inside the unit. So it's a self-contained unit, which has a refrigeration coil within it, which tempers the air in the hot seasons here. So that refrigeration coil will cool it down before it pushes it to the floors. And conversely, there's a hot water reheat coil that does the same thing to temper when we're in colder conditions. So the hot water coil is glycol based. So how this building and system is set up is we have our rooftop package unit, and then we have in the sub basement is a heat exchanger with a glycol loop and pumps. So I will show you that. I'm going to stick with, we're up here at the unit. This is what the rooftop unit looks like. So that outside air is coming in, and then there's, depending on what's taking place, what season we're in, where it's either the DX coil or the hot water coil, and then that pushes the supply air down to the floors. So they built shafts for this ductwork on each side of the building. So we had a shaft that would have the supply air and exhaust air ductwork. What we had to do is install fire smoke dampers on all these branch lines at each floor. Those were hooked up to the fire alarm with 120 volt actuators so that those things close in the event of a fire. After that fire smoke damper, though, we had to put in volume dampers. This project was based on phases on the remodel. So every single floor that we remodeled, we had to adjust those volume dampers accordingly. So anyways, that's what the reference on this drawing is fire smoke dampers at the shaft liner, volume dampers, adjusting the CFM to each floor as the balancer required. But basically, that's it from the ductwork perspective, is supply air and exhaust air going down the chase. And we have, sets of branches at each floor to serve that floor for ventilation. All right, on the piping end of this, we have glycol supply and return coming from the mechanical room in the basement, which is what's represented here. Like I said, I think I said in the beginning of the video that we had 2 of these DOAS units, one on each side of the building. So they're both replica models, replica installations on each side. The supply and return piping, we have 2.5-inch welded that gets up into this attic space and branches off each way to go to the rooftop unit. So as a part of making the schematic, I pull stuff from the submittal. I pull details from the back of the contract drawings. I kind of take different bites from different sections of the project and try to incorporate it into one as required. So, like, for instance, this one comes with a 3-way control valve. So they want to keep the glycol moving even if there isn't demand for it up at that unit. This valve will close, and the supply and it'll return back to the mechanical room if heat isn't required up at the unit. So let me cruise down here to the mechanical room. Oh shit! Go down here. All right. Okay, so this down here. All right, so first, the pumps are Bell and Gossett pumps. Summer at Frank P. Langley was the rep for it. I'm going to give you a review here. So down in the sub-basement here is where we have a set of inline pumps here that push up to the roof. I think, I said before, the heat exchanger. So this glycol system will strictly be for heating application only. So this glycol never gets cooled. So it's strictly for heat. Let me zoom in on this. I keep doing that. So we got steam coming into the heat exchanger, 1/3, 2/3 control valves based on demand. Goes through the coil here and heats up that glycol going through the coil of the heat exchanger. Obviously condensate out. So glycol supply and return, cruise there. That's where it picks up the heat to take it up to the roof to that coil. So we got a relief valve if ever it overpressurizes, air separator, getting the air out of the system. We've got a main fill for when we fill this thing. I gotta calculate the piping lengths so that we can get a volume count for that. We got our glycol feed unit. Let's see if it says. Yeah, 50 gallon. Okay. So there will be a makeup glycol reservoir here that in the event that there should be a drop in pressure sufficient enough, this will turn on and will put that glycol back into the system. And then over here we have our hot water pumps. These are inlines. And then we have our expansion tank as well. So that this project is too vast to get it all in one video. So I'm going to break it apart into each of the components of the building. So that is the extent of the DOAS unit circuit. So just to recap, rooftop unit, outside air, depending on the condition, it gets tempered one way or the other to what is ideal. And it's pushed down as ventilation air for all of the floors. And the heating component will be glycol. The cooling component is the DX coil in the unit. Now, the only thing is the controls portion of it. This is a self-packaged unit. So we could go into that controller and set everything to the parameters that we want, and this thing will run sufficiently on its own independently, and we could backnet it back to the BMS system. But in this particular project, they wanted to be able to have control of the unit. So for that, it will require a lot more controls involvement because they want to be able to adjust set points and adjust fan speed and stuff like that, which requires a lot more work than just being backnetted out. So The only thing that I would say about this is definitely look at the wiring diagram if you have to install one of these, because it will tell you a lot about how the controls portion works. And not on this project, but on another project that we installed a similar unit, ran into an issue at startup because, with it being a self-packaged unit, I was under the presumption that we didn't have to add anything more, but we do need to add sensors for the static pressure as well for the exhaust. So that would be one thing to make note of. Look at the wiring diagram and see if you do have a situation where the back net is all that's required. They just want to see it on the graphics. That you definitely want to put in. Make sure that we get that static pressure probe in there. Otherwise, that unit will not run. So that's DOAS unit. Thanks for watching.